Assalamu alaikum. We'll be discussing a little bit more about correlations and covariances in this video. From our early discussion, we know that correlations and covariances try to measure or quantify the association or relationship between two continuous values. And by this association, we mean the association or relationship of change. So if there's a change in one variable and there is a change in the other variable simultaneously, both of them are considered to be correlated. Please recall that correlation does not mean causation, which is that if there's a change in one variable, it does not necessarily cause a change in the second variable. There might be a third entity, a third variable which is causing, making both of them change together. But it is these values changing or varying together, which we study and which is signified by the term covariance. The relationships that we study between variables through correlations and covariances has two aspects. The first one is direction, which can be positive or negative. By positive direction or positive correlation, we mean that both of the values, they vary in the same direction, which is either they're increasing together or they're decreasing together at the same time. So if one experiences an increase, there is an increase in the other one. If one experiences a decrease, there is a decrease in the other one also. But with negative correlation, one value is increasing and the other value is decreasing. The second aspect of this relationship is the strength, which tells us how closely two values are changing together, how closely they are correlated, which is with stronger correlations, if there's a change in one value, there's definitely going to be a change in the other value. With weaker correlations, there can be instances when there's a change in one variable and there's very slight or negligible change in the other one. But this does not measure the magnitude of change. So if there's a change in one variable, the strength of this correlation does not tell us how much change will there be in the second value. There are other tools to do that. Covariances only tell us the direction, which is either the relationship is positive, both values varying in the same direction, but correlations tell us both. They do tell us the strength of the relationship. For example, the longer times you walk for is positively correlated to the number of calories you burn. The longer times you walk is negatively correlated with the amount of energy you will have afterwards, typically. This is a graphic showing a positive correlation, and it is between temperature and ice cream sales. So we know that if there is an increase in temperature, we expect the sales of ice creams to increase also. So you can see positive direction, which is signified by the upward trend, which means the x-axis value increasing. There is an increase in the y-axis values also. And you can also see that the trend is quite the pattern is quite well defined. The dots are scattered a bit, but they're not scattered that much. So we can infer from this graphic that the relationship is somewhat stronger positive relationship. Here you see the relationship between consumption of coffee and IQ level. So by the scattering the dots of the scatter plot, you can clearly see that there does not exist a correlation between these two quantities. Here, there is another correlation, positive correlation between height and weight. And once again, you see no correlation between shoe size and the number of movies watched by a person. Now, it's time that we compare the correlation. Then they can have further improvements in their design and have more fuel efficient vehicles. Um, Correlations and covariances have um, applications in medicine and healthcare as well, such as a medical researcher investigating the relationship between smoking behavior and the incidence of lung cancer. They can identify the correlation and covariances between these two um, quantities to find out if there's a risk of developing the lung cancer. Correlations and covariances find applications in medicine and healthcare as well, such as in this example, that if a researcher is investigating the relationship between smoking behavior and the incidence of lung cancer, so by analyzing data from a cohort study and calculating the covariances and correlations between smoking intensity, measured by the number of cigarettes they consume every day and the risk of developing lung cancer, they can quantify the strength of association between smoking and uh, risk of this disease, providing valuable insight for the public health interventions. Social sciences and psychology, for example, a psychologist is studying the relationship between socioeconomic status and academic achievements among school children. So, by collecting data on family income, parental education level, and student grades, and then calculating the covariance and correlations between these indicators about the someone's economic status and the academic performance of the kids, the psychologists can assess how these factors, how the social status of a child can influence their educational performances or outcomes. And then policies can be adjusted accordingly. Let's have a look at an example demonstrating how correlations can be calculated manually. So this is a table which shows data on investments in millions given as X and the percentage of profits given in Y for 10 different cosmetic brands. And now we are to find out if there is a correlation between these two variables, for which we need to find some intermediate values, which is X minus X bar for each of the X value. Here we have Y minus Y bar for each of these value, for which we have already calculated here the mean. Here is the mean of X. Here is the mean of Y. We know how to calculate the mean. All the values are added up and divided by the total count. So then we calculate the deviation. This X minus X bar is basically the deviation of every value from its mean. So this is 6 minus 21.3. This is 12 minus 21.3, and we get these values here. Same is for the y values. And then we multiply these two to get a, then from this we also compute this. This is the product between the two the deviations, and then we have the squared deviations also. Why? Because this is the expression using which we calculate the correlation. So here we have to compute this term, which is x minus x bar multiplied by y minus y bar for the corresponding x and y values. And then we also have to compute the squared deviation and take their sum. So here we do this. This is x's square deviations, and this is y's deviations, which we square. And here we calculate the sum of these values. So essentially, this is reduced to this, which is sum of this product between these individual deviations, and then divided by this entire thing, and we get 0.947 as the correlation coefficient value, which indicates a very high positive correlation. We do not see any negative sign, so this means an increase in the x variable is going to bring an increase in the y variable, and this association is very strong. So if there is a change in x, there is definitely going to be a change in y also. If we are to calculate the covariance, this is the expression for it. It only deals with the deviations from the mean values, and we take the product, and then we divide it by n minus 1. This is basically n minus 1 is a term which signifies the degrees of freedom, and we'll be looking at what this means shortly. But first, let's calculate the covariance value. So here we have this term calculated as 1172.7 from this table, and we divided it by n minus 1, which is sample size minus 1, and we get 130.3. So here you see This value, the correlation coefficient is going to range from -1 to 1, but the covariance value can range from -infinity to infinity depending upon the scale of the values, the magnitude of the values that you're working with. Coming to the degrees of freedom, we saw that earlier in calculation of variance also. And at that time, we deferred the discussion for a later lesson. And here now is the time that we discuss it. So degrees of freedom basically mean the number of independent pieces of information available for estimating a parameter. Here we are estimating the covariance. But even if you're calculating variance for the population, we're actually dealing with a sample. You derive a sample from the population, which has its own variability, and sometimes the samples might not be completely representative of the population. So in that case, the variability of the population is not totally captured by the sample that we've taken. So if we estimate the variability of population from a sample which is not truly reflective of the population, then this estimation can be biased. So to reduce the error or to reduce the bias, we consider only n minus 1 independent pieces of information. And also be used for prediction. So if x is correlated with y, the value phi can be predicted using the value of x. For this, we need to train a model over many values of x and y. And this is what machine learning does. A model sees the value of x and the corresponding value of y, and then it does it for many such pairs and tries to identify an expression which can compute the value of y or change in y based on the magnitude of change in value of x. And one of the tools that can be used to compute the magnitude of change in y based on the change in x is regression. Here, the independent variable or the predictor is used to estimate the value for the target or the dependent variable. For example, the CGPA, which is a target, can be predicted based on the number of hours a student has studied, which is basically the independent variable. So what actually happens is that these are our data points that we know, and this is the range that x can have or the independent variable can have, but we do not have a data point here in our data set. So now we need to define a model or a line of fit which tries to um, define the relationship between these variables as close to these true data points as possible. And here, the deviations from this line of fit that you see are basically the errors in predictions. So if we did not have a value such as this value in our data set, this value of x wasn't there because we do not see a point over here. So now we can predict for this value of x what the value of y would be by extrapolating this line. This is exactly what regression does. And you will be seeing this in detail in machine learning course. 1999 value.